Hi all, welcome to day 18 of Advent of Elixir. So in a previous video, I showed you how to connect up a second Erlang virtual machine onto your system. And what we noticed was on the other virtual machine, we didn't have any of the code loaded. And what I'd like to show you is how to actually get that code loaded. So you don't have to transcribe this code off of the screen. I've provided this code for you in a GitHub gist that I'm going to link to below. But what we'll do is we'll just go over this code a little bit. And the idea is that this code is designed to be written in such a way that you can pretty easily stick it in something like testhelpers.exs. Or if you want to create your own module, you can do the same. I'll also point out to you places where some of the values you may want to play around with to get them just right. Okay, so let's get started. In this function called startPeer, what we're going to do is we are going to run netkernel.start. This assigns a name to your Erlang node. I find that when you're doing automated solutions, it's a good idea to use something called a fully qualified domain name as the host for your atom that identifies your node. When you're setting things up manually, it's possible to use short names, but I think for stuff like CI, you can get in trouble if you don't use something that's a fully qualified domain name. And for testing purposes, the easiest fully qualified domain name is localhost, so you should use 127.0.0.1. The next thing is you have to set the cookie on the local node, and that's how you do this with erlang.setCookie. Then you're going to want to use the peer.start command, which I described to you in the previous video. However, in this case, note that I am using the host parameter, which I didn't use before. This will force it to use 127.0.0.1 as its fully qualified domain name. And of course, since this is an Erlang parameter, you're going to want to make this in a char list. That's what that sigil C with a single quote is. Finally, we're going to set the cookie on the remote node. And remember, we still can't connect yet. So we're going to use peer.call to set that up. And that peer is represented by this peer PID, which is a connection token. And this gen server is managing the connection between this node and the peer node. Finally, we're going to connect the two nodes so that we can stop using peer and use RPC instead. This will establish a connection over Erlang distribution between our peer node and our current node, and we have everything we need to get that to work. Okay, the next thing we're going to do is we want to add code paths. So remember, whenever we do these rpc.call function calls, the way to remember it is it's going to call this module with this function and with these as the parameters. So we're just going to be calling code.addPaths and then code.getPath. Now remember, for most cases when you're doing testing or CI, the Erlang virtual machine is going to be running in a directory that contains all the code that it needs. If you were doing this over some sort of remote connection, you need to make sure that the paths are the same. Otherwise, this will not work. So you may have to change this if you are doing something weird, like running a test runner over some sort of network where you have a pre-established server. I doubt you're doing that, but just for full disclosure. Then what we want to go through is we want to go through every single one of the applications that's loaded and set up the application configuration. So this is basically the equivalent to a config.exs script, but since we aren't going to run those config scripts remotely, you might want to do it this way. Here's a good place if you want to have some sort of configuration that is different between your primary main node and your peer node. This is where you want to intercept that and change it. Alternatively, you can do a config. You can use the config module to execute the configuration code that you would do on the remote node. That works too. But basically, this is just dumping application.getEnv and then running a putenv command on the other side. And the last thing we want to do is we want to start all applications. And this uses the application.ensure_all_started command. In this case, we're going to be running mix first because that is, remember, our compiler and build tool. And then we're going to run through every single one of the loaded applications on the main node and just running application ensure all started on that one. This will bring up all the gen servers, all the services that your libraries might have created, and also ensure that those modules are compiled and ready to go. I do want to point out one thing here, and that is to make sure that likewise all of your dependencies are in the same directory tree. Again, this is something that normally is not going to be a problem because the peer node and the local node are going to be starting from the same directory tree. Note that we have to start mix first before we run these because some of the because we want to make sure that our compiler is ready to go, and also our application configuration needs to come before our applications themselves because there may be some compile time configuration that gets set up in this block. Okay, so with that said, let's run it and see what happens. So currently in this VM, I have the JSON library set up. So let's do that. And so you can see that this works just fine on our local node. Of course, I haven't started up a peer node yet, but let's go ahead and do that. So we're going to do advent.startPeer. And it says, okay, notice that now we have our node name here, so main at localhost. And what I'm going to do is I'm going to do an rpc.call. And then we're going to do this on peer. Then we're going to call JSON, and then we're going to call decode. And then we're going to pass it our JSON string. And you can see that we ran this code on the remote side, and it worked out just fine. Let's also do one where we're going to actually demonstrate that the results are different on the peer node as from the main node. So node.self is a good one. And you can see that when I call it via the RPC call, we're going to get the peer node. And if I run it locally, we're going to get main node. So yeah, that shows you that we can indeed bring up basically the entire Elixir ecosystem and all of our libraries on a peer node. So hopefully that helps you. I will see you tomorrow.